Okay, so let's just make sure that we have a recording going. We do? All right. So talking about the formation of the solar system, and more specifically the Earth, we need to start somewhere specific. And that is with where the stuff for our solar system came from. Okay? Where the stuff for our solar system came from. If you do not have your notebook out, I would recommend pulling it out. If you do have it out, then you are prepared and you get a proverbial gold star. Okay. So this is really the question that I want you to ponder. Italiano. Italiano? Okay. So where did the stuff from our solar system come from? So in the Big Bang, there were a whole bunch of things inside the Big Bang, right? When the Big Bang happened and the universe expanded, all that stuff was just hydrogen atoms. Okay? So the Big Bang really just created a whole bunch of hydrogen atoms. This really best. Beautiful, okay? Hydrogen atoms, which are just single protons, really. Is the universe made out of only hydrogen atoms? Okay, so how did we get here, right? How did we get here with all of the stuff that we have in the universe, all the different things? So when the stars started to form a few million years after the Big Bang, stars do this thing called fusion. Okay? Fusion. Does anyone know what fusion is? I know my writing is so beautiful with this mouse.
Yes, it is.
Fusion. Okay? Fusion is when two things become one thing. And this is specifically nuclear fusion. Nuclear fusion. Is anyone in the astronomy class with me in this? Daniel is, yeah. So fusion is when two things become one. We're not going to go into as great of detail as we do in astronomy, but I want you to understand that when two hydrogen atoms run into each other, they create a helium atom, okay? A helium atom, oh, beautiful, so beautiful, okay? Hydrogen atoms run into each other, they create a helium atom, okay? And when that happens, it releases a lot of energy, at least for these little tiny things. It releases a lot of energy. This can only happen in the core of a star. Only stars have enough energy, enough mass to crush atoms so tight together that they actually fuse together. We as humans have figured out a way to do this, and we call it thermonuclear weapons. Okay? We call this process thermonuclear weapons. We as humans have figured out how to do this, but not in a controlled manner. We just know how to blow things up.
Yes, that's the only important thing.
That's how we do things. For reference, our sun is essentially several million nuclear weapons exploding every second.
Oh.
Okay? So you may have heard of the hydrogen bomb or the H bomb. This is what is going on. Fusing two hydrogen, well, more than two, but fusing a bunch of hydrogen into helium to create a large amount of energy. Okay? So that is where more stuff is made. So the universe really just started out as hydrogen, and then we got some helium, and then helium, and you can see the periodic table on the wall over here. Helium can fuse with other hydrogens to make lithium, or helium can fuse with other helium to make beryllium, and so forth and so on. Really big stars are required to make the heavy elements, okay? So stars manufacture complex elements in their cores, okay? Right? They manufacture through fusion, all right? Fusion. So we end up with carbon, and we end up with silicon, and we end up with palladium, and gold, and silver, and lead, and all these different things, because the stars are able to fuse atoms together. This is the only way that we make new elements, is through fusion, and that happens almost exclusively, with the exception of nuclear weapons, almost exclusively happens inside of stars. Okay?
Can that happen in the core of Earth?
No, not even close. The Earth is not even 1/100th of the size that it would need to be to create fusion.
I'm wondering something. Is the center of the Earth as hot as the surface of the sun?
Yes. The surface of the sun, but the core of the sun is several million degrees. And at that point, it doesn't matter if it's Celsius or Fahrenheit. It's just hot, okay? It's real hot, okay? So stars manufacture complex elements through fusion, in their cores through fusion, okay? Well, then they explode, okay? And when they explode, or as the video, The History of the Whole World, I guess, would say, some stars die with passion, and they make even crazier space dust, right? So the space dust that Bill Wirtz talks about in that is these elements, okay? Fusion leads to an explosion of the star. Whoa, that didn't work. That's not what I want. Oh no, what have I done? I've done something bad.
What have you done?
Okay, I'm just gonna leave it a little skiwampus like that just to bug you all, okay? Fusion leads to an explosion of the star. And who's ready for one of Mr. Crowshaw's patented beautiful drawings?
Beautiful.
I know. And let's. Oh my gosh, it's so bad. I'm really sorry. Okay? Well, when they explode, all of those elements go out into the universe. Okay? I'm just going to add a few more, lines here to really get the point across. Okay. So this explosion puts out all of this dust and gas into the universe. Well, I'm going to move on here. The sun is a third generation, or generation 3, is a generation 3, and we use Roman numerals, star. Okay, sun is a generation 3 star. What does that mean?
I don't know.
Well, it is the third generation of star, yeah. So the first generation, we had some stars. Oh yeah, really so beautiful. Star, and I'm just going to label it with a Roman numeral 1. Okay, star generation 1. Okay, those stars went kablooey. My drawings are just getting better and better, guys. Just so good. Okay. Star generation 1 exploded, okay? And they had created elements in their core. And so now when they exploded, now instead of just being red, this explosion also has some blue in it. Okay?
It's blue.
And a generation is born, a generation of star is born after that is both red and blue. Okay? And this is generation 2. Okay? This is generation 2. Well, this star makes more crazy space dust in its core, more elements. And when it explodes, it's not just, oops, it's not just red and blue. Okay, it is also red and blue and green. And what do the colors represent? Different materials, right? Okay. It's a star. Okay. Maybe. Well, all of this stuff coalesced to create the sun. Here, green. Okay? And the sun oh, that S is bad. Oh, it's so bad. The sun, which is a generation 3 star. Okay? So we're going to pick up our story. We're going to pick up our story after the explosion of generation 2 stars. Generation 2 stars. Okay, so this is the beginning of our story. What's up? Well, yes, but the thing is that I have a beard and a mustache, and every once in a while, that the hairs in my mustache will curl up. And they'll touch just the very end of my nose. And it is the most obnoxious thing ever. Like, I try and like comb down or whatever, I just end up pulling it out because it's just like, it makes me want to sneeze the whole time. All right. Speaking of masks, I'm going to put on my different mask here. My wizard mask. Okay. So after the explosion of generation 2 stars, we are left with a nebula. This is an important term for you to understand. It is a cloud of gas and dust in space. Okay? A nebula is a cloud of gas and dust in space. So after those generation 2 stars exploded, they went kablooey, right? And all of the stuff that was inside of them was scattered amongst the universe, and they created a nebula. Okay? So our nebula is just this gas, and oh my gosh, it's so bad. Everything's so bad. I kind of want to draw it, but I kind of don't at the same time. In fact, I'm actually going to go over here and draw it. This? Yeah. Okay. I'm going to come over here and draw it a little bit. So we have a cloud of gas and dust in space. Okay. It's full of all this stuff. Okay. It's just a cloud. Nebula is actually the Latin word for cloud. So, and looking out into space, if you get a telescope and you look at a nebula, it really does just look like. So here, can I do this? There we go. Nebula. Oh gosh, typing upside down is difficult. Nebula. Boop. Okay. That's what a nebula looks like. Okay, they're pretty awesome. This happens to be the Orion Nebula, which I've seen many times through my telescope. This one is the Eagle Nebula. Okay, so this is what a nebula looks like. Okay. Obviously, my drawing and those pictures are exactly the same. You know, my art skills are unrivaled. Okay, so a nebula is a cloud of gas and dust in space. Any questions on where we are in the story after the explosion of generation 2 stars? Okay, let's carry on. So when the nebula is in space, there's this thing that you may have heard of called gravity. Gravity, okay? Gravity, so we have our nebula here, and yes, it's gonna be beautiful. Okay, let's just add in a little color here, because I, want to be fancy. A little bit of green, and some, and some blue. Okay, all this stuff in the nebula. Well, gravity starts to pull the nebula together. Just ever so slightly. Remember, this is dust and gas, and it's really spaced out. And when I say really spaced out, it's more spaced out than air. Okay, it's way just all spread out in space. Okay, but it starts to collapse under its own gravity. Gravity, okay? The arrows mean gravity. Okay, so as this cloud of gas and dust begins to collapse in on itself, something happens, okay? as things move in toward the center of mass, something happens with what is called the conservation of angular momentum. Okay? The conservation of angular momentum. I'm going to stop sharing here for just a second.